Good roofing practice for a self-adhered single-ply installation will include
roof debris, making sure it's clean.
Do a mock-up so that you can verify that the material properly bonds to the substrate.
I'm kind of thinking of an alternate use. This product could really be helpful in emergency situations.
I'd say seam integrity, because it's a peel and stick, because it's a single ply. It's that much more critical.
Assure you've got accurate layout prior to pulling any release paper or tape so that you can eliminate waste. It'll save you a lot of money and time.
Make sure you got proper alignment, because once it's stuck down, it's there. That adhesive is more tenacious than I ever imagined it would be.
I would just say consider using the accessory materials with traditional TPO systems, for example, stripping in a metal flange.
One of the problems with single-ply roofs is the possibility of leaks where three pieces of membrane intersect. These are called T-joints. To minimize the possibility of putting the T-joint patch in the wrong spot, we recommend that the membrane be cut on a 45-degree angle as shown here. That way, when the membrane's folded down, the T-joint will be applied in the only logical place. Prior to installing the membrane at the T-joint location, a bead of caulk is placed along the cut edge. This is really just to prevent any water from wicking along this cut edge and into the substrate. You have to be careful not to get too much caulk on the edge of the area where the T-patch is going to go. Typically, all corners on patches and seams are rounded to prevent any possibility of the membrane peeling up. And prior to installing the end laps on the sheets, the membrane underneath is primed, and then the sheets rolled into place, and then the seam rolled. Again, notice how the 45-degree cut forces the mechanic to install the T-joint patch at the right spot. Patch is installed and rolled. Seam sealants just to prevent any possibility of moisture wicking into the reinforcement in the thermoplastic membrane. Typically, it's recommended that seam sealant be applied at the end of the day. That way it minimizes the possibility of anybody stepping in the wet sealant. Where seams run up the wall, a T-patch is put in the corner transition. First the membrane's primed, and then a T-patch is placed in the area and rolled. The last step in the process is to apply seam sealer along the seam. When flashing around round penetrations, it's important to put primer on the TPO membrane. That softens the surface and cleans it and provides a suitable bond to the underside of the membrane. Allow the primer to dry and then place the patch over the cut around the pipe and pass the seam. Make sure the patches on all cuts extend 6 inches out in all directions. Press it in place and then use a hand roller as you would on a regular seam. With most thermoplastic reinforced membranes, seam sealant needs to be applied around all cut edges of the membrane on patches and on end laps in the membrane. Typically the seam sealant is a liquefied form of the polymer that's used to make the single-ply membrane.
What Chad's going to demonstrate is a common mistake with cutting the boot, and what will occur is if you make jagged cuts rather than a circular cut, these will tend to telegraph out a year or two later and split and cause leaks at the pipe penetration. So those should be cut perfectly round. So he's demonstrating how not to do this, because as it stretches, you're going to see that this starts to expand and crack. When he comes back to put the stainless clamp, this will actually extend out beyond the clamp within a year to two, and cause a leak. So what he needs to do is make a clean cut on the boot prior to pulling it on and installing the clamp and caulking.
The last step in the process of flashing a round pipe is to put the stainless steel clamping band around the top of the pipe boot and then tighten it in place. And then caulk sealant is installed around the top of the flashing.
What we've got is a condition where there's an underdriven screw, and that's been damaged with foot traffic. It can cause a puncture or penetration and leak. It needs to be corrected. When the patch is installed improperly without cleaning the substrate and properly priming it, it can be easily removed or leak in the future. So the patch needs to be installed properly following manufacturer's guidelines by cleaning the substrate properly, installing a primer, and patching 6 inches beyond the affected area. Allowing the primer to dry and installing the patch, rolling it in place to assure that there's no trapped air and that the edges are fully sealed. Trapped air could result in a blister, further punctures, or delamination of the sheet. Applying a edge caulk for the cut membrane edges. This problem can be avoided by auditing the installation and assuring that all of the screws have been properly set prior to the installation of the membrane.
One item that's very important is the stability of the substrate that's below a single-ply roofing system. You want to have a substrate that will be able to resist some degree of impact damage from falling tools or from other types of items that are on a roof surface. Obviously, we have damaged roof insulation that's slightly crushed. At this crushed point, when the single ply is put over the top, we can have a loss of adhesion, and this can promote blow-off or delamination of the single ply. When we have a harder substrate or a more dense substrate, then it's much more resilient or much more resistant to impact damage. One thing that really helps is to put walkway material around your mechanical units or around your high traffic area. We've got a walkway that we've installed over the single ply, and we'll do the same type of impact test. We may have a little bit of a dent in the walkway material, but one thing that hasn't happened, we have not punctured the membrane that's below. So the bottom line is the roof won't leak, or we won't be as likely to have leaks from falling equipment.